So we have solved first part of the question, in which we have shown the force is acting on the particle, right, in this question. Now we have to solve part 1, which is saying find the least possible value of P. Okay, here, find the least possible value of P. Now, which diagram do you think will fulfill this situation? Will it be about to move down or about to move up to find the least possible value of P? Okay, so least or smallest amount of value so that it can prevent the particle from slipping down the plane will be the condition in which particle is about to move down, right? Because we are applying very limited force, applying very small amount of force. So we will make use of this diagram to solve part 2. Now how we will solve it? So first of all, consider Newton's second law of motion. Okay, I always take this in the case because it is in limiting equilibrium. So this part will become 0. It means forces will be balancing each other, right? This part is 0, forces are balancing each other. Now these two forces, frictional force and applied force, are acting upward. Which force is acting downward? Can you see here? So let me draw here. Okay, I will resolve this weight force, which is 120, into perpendicular and parallel to the plane. Okay, so this angle is 25 degree. So what this will be, this downward force, which is opposite to normal force. I'm writing it N or R, whatever you want to write here. So this is actually 120 cos 25 degree, right? And what about this force, what it will be, which is acting downward due to weight? It is 120 sine 25, right? So now if you see, these two forces are upward and this is downward. So I can say Fr plus P is equals to 120 sine 25, right? And I will tell you why did I write it. Just give me a minute. First of all, I'm talking about here forces are balancing each other. Similarly, this normal force, perpendicular force, is balanced by 120 cos 25, right? This one, which is acting downward here, and this one was acting, blue one was acting upward, 120 cos 25. And this is also called R reaction, normal reaction, right? So maximum friction, Fr, frictional force, is maximum when particle is in motion or it is about to move up and down. The limiting equilibrium condition, the maximum frictional force is applied. So which is equals to mu R, you know that. The value of mu is given in the question, which is 0.35. Okay, so 0.35 into R is 120 cos 25. Okay, so let me take a calculator and solve it. 0.35. 0.35 into 120 cos of 25 is equals to 38.0649. Usually I use the whole value which is given in the calculator. So now I have the value of Fr, which is 38.0649 plus P is equals to 120 sine 45. Let me check what is this. 120 times sine of 25, right? This is equals to 50.714. So my P will be this value minus 38.065. I'm just rounding off or not, doesn't matter. 38.0649. So least value of the force P which is applied is P is equals to 12.6 12.49. If you write in 3 significant figure, it will be 12.6 Newton. So this is the least amount of force you are applying. Okay, so thank you very much for watching. Please press like and subscribe button. Take care. Allah Hafiz.